There is a wide variety of electrical and electronic equipment that require a high continuous voltage, such as microwave ovens, cathode ray tubes, and among others. Voltage multiplier circuits are used to satisfy this need. In this project, a half-wave voltage quadruplier will be constructed, which will multiply the peak input voltage by 4. The circuit is built with diodes and capacitors, and this operation is due to the successive loading of the capacitors, due to the cascade enablement of the diodes, which at the same time serve as rectifiers of the current. The first capacitor is charged with the input voltage by means of the first diode. The second is charged with the voltage of the first and the source by means of the second diode. The third is charged with the voltage of the first capacitor and the second by means of the third diode. And the fourth capacitor is charged with the voltage of the first capacitor, the second and the third by means of the fourth diode. In this way, the fourth capacitor will have the input voltage multiplied by 4, and therefore its electric field also will be the input electric field multiplied by 4.
The team agreed to use 6 diodes of N14007 and 10 polystyrene capacitors of different values, as well as use 2 resistors of equal resistance to measure the voltage difference and the current located in the circuit. For a simulation, the multi-chip platform was used, where we began by using almost the same diagram that was provided to us by the teacher. When perceiving that the diagram didn't give the necessary values, which were 720 volts with a tolerance of 5%, this means that we had the possibility that in the circuit it came out 684 to 756 volts with a minimum current of 1 milliamperes. In the simulation in our circuit, we obtained the quantity of 696 volts output with 1.3 milliamperes of current with values of capacitors and commercial resistors. The voltage forms that were perceived were the following, where it can be analyzed that the oscilloscope shows that the wave in the resistor reaches 305 volts. In addition to the average of the wave is reached to 324 volts, which is measured on the multimeter. The design of the PCB was carried out in the Proteus program, taking care of the measurements of the components that were to be mounted on the plate, such as the separation between the terminals, the thickness of the track of the plate, and the curves that were generated. Since you could find tracks that made 90-degree curves, it will make an interference and behave like an antenna, thanks to the reflected impedance it would have.
Hi, my name is Javier. I will show you the experimental results of voltage and current in the resistors, in addition to the waveform of voltage and current. For the first test, I will measure the voltage in a resistor with a multimeter. In the first resistance, we obtain a value of 3053 voltage. For the case of the second one, we have obtained a value of 3051 voltage. We know that the voltage in each resistance is odd because they are in series. For that reason, we obtained a value of 704 voltage. In the second test, I will measure the current that passes through the two resistors. For this occasion, the multimeter is placed in open circuit between the cable and where the resistance ends. Finally, we observe that the current is at 1.33 milliamperes. Here, we can see which diodes capacitance, and resistors are available on the board. So, for that reason, the current can flow and there is no short circuit. Of course, we have decided to record at different angles. Here we can see the PCB board, where we can see the connections on the back of the board. Besides, we can see that between the connections there are no perpendicular lines that form a 90-degree angle. The corners were replaced with rounded shaped corners. The third test consists of analyzing the waveform of the voltage and current in the resistors. We have placed the oscilloscope in the terminals of the two resistors. We see that the waveform is sinusoidal and has a square shape. This represents the sum and voltage drop.
In conclusion, the waveform obtained by the voltage multiplier in a physical and experimental way is very similar to that obtained in the Multisim software. In other words, it was a success. The simulation is identical to that obtained by the oscilloscope, showing that the calculations made were correct, as well as the printing on the PCB. During the development of the project, we had some problems, such as the perforation of the printed circuit board. But the project consists of more than a printed circuit board. It consists in finding creative solutions to the problems that may occur during the elaboration of it. In addition, it can be the beginning of many other projects or investigations, which have a practical and palpable application of electromagnetism, because in video game consoles, CRT televisions, electrical wiring, among other things, they use the electromagnetic principles that we have applied with success during this project.